What did I learn from week 8? It's like the VR experience is like it was really good. I also would like to have it, but I'm from Concepcion, so I didn't have the opportunity. The other thing that I learned is that uh, how can the how can we detect planets from other stars? And it was like with five four no, with was three ways, and that's it. Then now for activity one, the question of the activity one of week 9, it was uh, what is this the source energy source and if it's unlimited, and the source energy source is the nuclear fusion that is occurring in its core, and it's the the fuel is not unlimited because it's a finite supply of hydrogen that fuels this nuclear fusion. And but this fuel would last approximately another 5 billion years before it runs out and the sun evolves into a giant red. Then for the activity 2, what type of atoms are used in each process? The fission uses heavy, unstable atoms like uranium or plutonium, which are split, and fusions use light isotopes like hydrogen or helium, which are they can be combined. Then for the second question of activity 2 is which ones produce radioactivity waste and why? Fission produce high levels long-lived radioactivity waste because they use unstable and heavy atoms, and this is why they produce radioactivity waste, and this can last like 1,000 years. Is really dangerous. Then the third question is in the event of failure of a nuclear power plant, uh, well, a fission plant risks an uncontrolled chain reaction leading to an accident of the or called meltdown that happened on Fukushima or Chernobyl. And a fusion plant is inherently safe because any disturbance can cause the reactor to stop almost immediately as the plasma cools. It's not like really a big thing. Then, which plant would be considerably dangerous, fission or fusion? The fission is considerably more dangerous because it relies on a self-sustained chain reaction that and, uh, and produces a long-term high-level radioactive waste. And, and fusion plants is safer because it's a self-limiting process when the failures only shut down the reaction. Then, is a nuclear fusion the energy of the future? If so, why don't we use it? Yes. Yes, nuclear fusion it widely considered the clean energy of the future because uses abundant fuel, is hydrogen's also isotopes from water, and is inherently safe and produce virtually no long-term radioactivity waste. Now for the activity 3, how does the sun maintain the stable energy production rate? The sun maintains a stable energy production rate due to a self-regulated process called the solar thermostat. And this equilibrium balance between two opposite forces. One, the gravity, the immersive mass create a strong inward gravitational force that constantly press the into the star, and the other one is the thermal pressure, the nuclear reaction, and the the electromagnetic fields it's pulled outward, creating these nuclear reactions, core generating incredible heats, creating an outward thermal pressure that pushes away the gravitational force. And these two forces are that the thing that maintain a stable production rate in the sun. And what will happen if the sun, once it no longer has hydrogen in its core, if the sun has no longer hydrogen in its core, it will have helium, and the star would change to a giant red. This new phase has helium fusion, and the sun will no longer give the heat that is giving this long time. It would get colder, but it would get like a really massive star. It will not like be the size that has now.